Hello everyone, welcome to Wi-Fi Learn. In this video, we can see some nodal analysis problem and we can solve those problems by using a Cramer'S rule, that is matrices and determinants. So let's move on to the problem. Using a Cramer'S rule, solve the network and find the nodal voltages. Here the first step of the nodal voltages is, nodal voltage method is, find the number of principal nodes. Here the principal nodes are 1, 2 and 3 and consider any one of the node as a reference. Consider any one of the node as a reference node. Here the third node, take this as a reference node. Reference node must be grounded. And 1, 2 other principal node. The two principal nodes are 1 and 2. So we need two equations. Or we need a 2 cross 2 matrix of 4 elements. So I'll first write the principal nodal equations of first node and second node. In the first node, assume the first node is in higher potential, the current will be leaving, right? Some of the current would be leaving here, 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 here. So according to KCL, the leaving currents, sum of the outgoing currents is equal to sum of the incoming currents. So leaving currents are V1, the voltage across the first node is V1, V1 divided by 2 plus V1 minus 25 divided by 5 plus V1 minus V2 divided by 10. The voltage across the second node is V2. This is the first equation and the second nodal equation would be of V2 minus V1 divided by 10 plus V2 divided by 4 plus V2 minus 50 divided by, V2. Here the voltage has been reversed, so V2 plus 50 divided by 2 is equal to 0. This is the second nodal equation. So by using this itself we can form the matrices. Taking the common out V1, you will get a first self matrix. If you take this here V2, this is the resistance which is common to first and second node. So I will write the matrix format. 2 cross 2 matrix. First element would be self resistance which is connected to the first node. The self resistance are 2, 5 and 10. So 1 by 2 plus 1 by 5, so plus 1 by 10. And second is a common resistance which is connected to first and the second node. That is 10 minus 1 by 10. So resistance is symmetric matrix, minus 1 by 10 follows here. And this element is the self resistance of the second node. Second node, the self resistance are 1 by 10 plus 1 by 4 plus 1 by 2 into V1 and V2, voltage of the first and the second node, which is equal to the current to that node. See here, this is a positive terminal, the current would be leaving here normally. Right? The current will be start flow from the positive terminal to the negative terminal of the battery. So the current would be entering in this node. The current will be entering. What is the current value? Voltage is 25 and the resistance is 5. So 25 by 5 is 5 ampere current is entering. So the current is positive 5. Here the current would be flowing from positive to negative. The current would be entering here and across this terminal the current would be leaving. Right? In this node, the current would be leaving. So, then the leaving current must be represented as negative. Current is 50 divided by 2 minus 25. So, minus 25 amps is leaving here. Understood? The current is entering to the node, then the current value is positive. The current is leaving to the node, then the current value is negative. This matrix can be further reduced to 0.5 plus 0.2 plus 0.1 minus 0.1 minus 0.1 minus 0.1 plus 0.25 plus 0.5 to V1, V2 which is equal to 5 minus 25. Your del can be represented as 0.80 minus 0.10 minus 0.10, 0.85, a del value. On doing calculation, 0.80 into 0.85 minus 0.10 the whole square, which is equal to 0.670. V1 can be found by replacing the first column of the del with the current values. So 5 minus 25 minus 0.10, 0.85 divided by the normal del value, that is expansion of the symmetrical resistance matrix, 0.670, which is equal to 5 into 0.85 minus 0.25 into 0.10, right, 0.670. On doing calculation, we will get the value as V1 is equal to 2.61 volt. V1 is equal to 2.61 volt. V2 can be found by replacing the second column with the current value. So, 0.80 minus 0.10, 5 and minus 25 divided by normal del value. So, V2 formula is del 22 divided by del, right. So, you will get the V2 value as minus 29.1. Since here it is negative, you will get a value as minus 29.1. So, from V1 and V2, we will get the value of I1 and I2. See, we have found the voltage at each nodes. V1 is equal to 2.61 and V2 is equal to minus 29.1 voltage. Minus 29.1 voltage and V1 is equal to 2.61. Now, we can find the current flowing through each branches according to these equations or by using matrices also. We can go through by equations itself. So, the first current is V1 divided by 2, that is 2.61 divided by 2 is the value of the value is 1.31 ampere. This 1.31 ampere current is leaving and the value is positive also. And the current through these branches V1 minus 25 divided by 5, right? That is a potential fall. So, V1 minus 25 divided by 5, which is equal to 2.61 minus 25 divided by 5. So, the current flowing through this branch is minus 4.478. Minus 4.478. The answer coming in negative shows that the current direction which you assumed is wrong. So, minus 4.478 current is not outgoing. Minus 4.478 is incoming. 4.478 is incoming. This is your assumed current direction which is flowing in downwards, but actually the current is flowing in this way and upwards, 4.478. And the current in this branch, common branch, V1 minus V2 divided by 10. V1 minus V2 divided by 10. V1 is 2.61 minus of minus plus 29.1 divided by 10. Your outgoing current is 3.71 ampere. It's your ampere. So, it is positive 3.71 ampere. Correct. So, now we have applied KCL in this node. Sum of the incoming current is equal to sum of the outgoing current. Here the incoming current actual is 4.478 and the outgoing current is 1.31 plus 3.71. So, it is satisfying. Okay. So, now we go to this node, V2 node. In second node, the currents are V2 minus V1 divided by 10. That is minus 29.1 minus V1 value is 2.61 divided by 10 is minus 3.71. So, ampere. So, it shows the current direction which you assumed is wrong. You have assumed current is flowing outwards, but actually current 3.71 is incoming. Okay. And in this branch, V2 by 4. Your V2 is minus 29.1 divided by 4, which is equal to minus 7.275 ampere. Again, here the current direction has to be reversed, which you are assumed is wrong. So, minus 7.275 ampere is incoming. And the last value, V2 plus 50 divided by 2. Your V2 is minus 29.1 plus 50 divided by 2. Your value would be of 10.45. So, the 10.45 ampere is outgoing, which your assumed direction is also correct. So, apply KCL in this node. So, some of the incoming currents are 3.71 plus 7.275, which would be equal to 10.45. Okay. By using the nodal analysis, we can find the value of the current which is flowing through each branches and the voltage at each nodes. Okay, now let's move on to the second problem. See, in this problem, it's very interesting. For the network, find Vs. They are asking the source voltage which makes the output current of 7.5 milliampere. Use the node voltage method. Why it is considered as a output voltage? Because it is an external resistor that is connected at the end. So this is an output load that is connected. Output current is 7.5 milliampere. Now we can use the nodal voltage method. Here they have given I0 is equal to 7.5 milliampere. Check out the principal nodes in the circuit. The principal nodes are 1, 2 and 3. Consider any one of the node as a ground. I am taking this third node as a ground value. By using the nodal analysis, we can use matrix or we can use equations also to solve it. I will use a matrix to reduce the circuit. So, there are 3 principal nodes. One has been taken as reference and the remaining node equations are written for these 2 nodes. The number of nodal equations for this circuit is 2. So, the matrix will be of 2 cross 2 matrix and it has 4 elements. Okay. The first element of this node is self resistance which is connected to this node. The self resistance which is connected to this node are 8 and through the source this 12 ohms is also connected, right. 8 plus 12, 20, 7 and 4 are self resistance which is connected to node 1. So, 1 by 20, so plus 1 by 7 plus 1 by 4. These are the nodes. And the common resistance connected to first and the second node is minus 1 by 4. As I already said, the resistance is a symmetric matrix, the symmetricity follows. And the last element is self resistance of the second node. So, 1 by 4 plus 1 by 6 plus 1 by 6 multiplied with V1 and V2 or the node voltages of 1 and 2, V1 and V2, which is equal to current flowing through the node or current which is away from the node. See, here the source is Vs, the current will be flowing through this source only, right, and the resistance connected to this source is 8 and 12 which is in series. So, the current with this branch would be Vs divided by 20, 8 plus 12 is 10. So, due to this source, the current flowing through the first node would be Vs divided by 20. Okay, there is no source connected to the second node. So, the current flowing is 0. This is a del matrix. This del can be reduced as 0.443 minus 0.250 minus 0.250, 0.583. This is a del value actually. They are asking the Vs value. This Vs could be found if we are finding the V2 value, right. For V2 only, the formula is del 22 divided by del. A del 22 can be found by replacing the second column with this value, right, by replacing the second column with this value so that the matrix can be solved very easily. V2 can be found by del 22 divided by del. A del 22 is replacing the second column with Vs, replacing the second column with Vs. So, this can be found by 0.443 minus 0.250 Vs by 20, 0 divided by your del value. Your del is 0.443 minus 0.250 minus 0.250, 0.583. So, this can be found as V2 is equal, this is 0, minus of minus plus 0.250 into Vs divided by 20 divided by multiplying those two values. 0.443 into 0.583 minus into minus plus, so 0.250 the whole square. On expanding this, we will get the V2 value as 0.0638 Vs. V2 in terms of 0.0638 Vs. In this circuit, we know that V2 is equal to 0.0638 Vs. And the current flowing through the output element is 7.5 milliampere, right? 7.5 milliampere. So, V2 can be found as, I0 can be written as voltage in this node, that is V2 divided by 6, right? According to this, I0 is equal to V2, voltage across this, minus the reference voltage is 0 divided by 6. So V2 can be found by using this formula, right? I0 is equal to V2 minus 0 by 6. I0 given in the problem is 7.5 milliampere, which is equal to V2 divided by 6. Your V2 is equal to 6 into 7.5 into 10 to the power minus 3. Your V2 value is 45 millivolt. So from this equation we can find the value of Vs, right? Your Vs is equal to V2 divided by 0.0638. Your V2 is 45 into 10 to the power of minus 3 divided by 0.0638. Your source voltage value would be of 0.705 volt. This is the reason why we have found out the V2 value instead of V1 value. If you find the V2 value, we can easily find the value of the voltage source V2 in terms of I0. Since they have given the output current, so V2 value can be found easily instead of V1. So that in terms of Vs, V2 is represented. After substituting the value of V2, we can get the value of Vs, source voltages. I hope you understood the concept of these problems. If you have any doubt, please leave it in the comment section. And if you like the video, please like, share and subscribe to Wi-Fi Learn. Thank you.